Today is the last class for quantitative techniques. So we will be dealing with index numbers, and we will also be dealing with hypothesis testing. Some little different. What is the meaning of hypothesis? What are the different kinds of hypothesis? And basically a little bit of how do you do the testing for different kind of means, different kind of samples. That is what we will try to cover in the 2 hours of class today. So first of all, I will start with index numbers. Again, for the last class, I'll try to switch on the camera, but because of the Wi-Fi fluctuations, the bandwidth is less. That's why I've not been switching on the camera for the entire time duration. Okay, so let me start with the class. So I'll explain the concept of index numbers. Now, index numbers is a very important thing in the sense that it tells you about, for example, if you want to know that you must have heard your grandparents telling you that prices have really increased since the time we were young. Now, how do we come to know? So we will say that something which used to cost 10 rupees is costing maybe 100 rupees now. So we can make out that there is a change in the price, but we want to find out what is the kind of change that is taking place. So we want to find out what is the kind of change in prices which is taking place. We also want to find out the kind of change in quantity which is taking place. For example, there can be two ways of understanding a change in price. So one can be that the price has changed, and the second is the prices remain the same, but now the quantity which you can buy with the same price has gone down. So this is how we want to find out that how much is the change taking place, what is the percentage of change which is taking place between different time periods. Okay, so that is what we talk about as index number. So it's a very, very important thing. It is used for finding out what is the purchasing power of money, means what is your money worth. It tells you about that. It is very useful in business. It is very useful for people who are getting salaries, who are doing different kinds of business. So for them, index numbers is something which is taken as a base, so that it tells them that if their salary is increasing, by how much have prices increased, or how much have how much is the cost of living index in a particular country. So there are many, many different kind of measures. I will be just dealing with some basic measures in today's class to make you understand the concept. Okay, so let's start. So the first concept we have over here is called as index numbers. And now index numbers are divided into many, many types. So you've got price index number, you have quantity index number, you have aggregative index numbers, etc. So if you draw this, basically it is divided into two important parts. The first is unweighted, and the second is weighted. So under unweighted, there are two important components. We talk about simple, aggregative, and simple average of relatives. Under weighted, again, we have two areas. The first is weighted aggregative relatives, and the second is weighted average. Okay, so these are the two main areas which we will be dealing with. So first we come to the unweighted and we come to the simple aggregative method. So here we write it as P01. What does it mean? It means base period to now. So for example, you want to compare what are the changes in prices from 1900 to 2020. Okay, so 1900 will be the zero period because that we are taking as the base period, and 2023 will be the one period which you are considering. So it is always written as P01, 0 standing for base period, 1 standing for the new period. Okay, so it's a very simple formula. Here we write summation of P1 upon summation of P0 multiplied by 100. Okay, we'll do a very simple question on this. So if you've got, suppose, commodity, so we've got A, B, C, D, and E, 5 goods that we want to compare. So we say what was the price in 2020 and what is the price in 2023. So price of A was 50 rupees, B was 40 rupees, C was 80 rupees, D was 110 rupees, and E was 20 rupees. And similarly, price of A was 70, 60, 90, 120, and 20. So we can, if you just look into it, you'll find that some things have increased quite a lot, other things have increased little. For example, nearly like A commodity, there's a 20 rupees increase, but C quantity, there is only 10 rupees increase. E quantity, there is no change. Okay. So there can be differences in different quantities. Some might be a huge change, some might not be a major change. Now, what do we find? First, we find sigma P0 and we add up and find out sigma P1. So summation of sigma P0 will come out to be, please immediately add and start giving me all the answers. Please give me the answer of both of them. P0 and P1. You can just write it in the chat box so that I know the answers. Let's see who's first in answering. I want to see that today.
300.
300.
The first
and
one.
The other one? Yes.
Yes.
And
correct.
The second one?
The second one is 350.
350?
Yes.
Is it? Just
no,
react.
360.
360.
Yeah.
360. Yes. Yeah. That is it. I think.
Yeah. Okay. Just one small thing. In statistics, no, be very, very careful with the corrections because I'm telling you because I've been teaching for a very long time. I find that majority of the mistakes don't happen where formulas are concerned or where writing is concerned. It's mainly in calculations. So just be very careful because these small changes in additions or multiplications or divisions changes your answers drastically. That's why generally I'm just giving this as a small tip to you all that we think we are adding and we are dividing and we are multiplying because we have been doing it, but major mistakes happen over here. So just recheck your answers many times before you make any submission. That is my tip for your exam. So definitely
Thank you.
keep in mind because I know that you will not make mistakes in writing your formulas or substituting it. I know that everybody does very well. Okay, so I know you all will do well. I have that faith in you all. So just be very careful. Cross check all your small calculations. Okay, so here now we come to P01. This will be equal to 300 sigma P1 upon sigma P0 multiplied by 100. So this is equal to 360 divided by 300 multiplied by 100. So what do we get as the value? What is the value?
120.
120.
So, yes. So what do we write as our answer? We will say there is a 20% increase in prices. Okay, why? Because I've taken 100 as my base year price. So from 100 it has become 120. So that's why I say there is a 20% increase in the prices. Clear? Is this first question clear to everyone? The first method. This is a very scoring area. If you are getting a choice and one question comes on any of these methods, please attempt it. Okay, because index numbers is a very scoring question and very easy questions, and you can very simple to do and very easy to score. Definitely choose the question on index numbers. Okay, now we come to the second question. This is the second part where we talk about simple average, or it is also called as price relative method. Okay, so here we are saying that you have to create an index, again taking 1 year as the base year and the other year as the year for which you are calculating it. But here the formula now will be little different. So we say it is P01 is equal to summation of P1 upon P0 multiplied by 100 divided by n. Okay, so here again you've got commodity. Same question I'm doing, but the method is different. So pay attention on what is being, where am I getting the 20% increase? See, 100% I have taken as the base year. Now, when you have calculated the value, you are getting 120. So 100 to 120 means there is a 20% increase. Is it clear? Lovely.
Yes, it is okay.
Okay. So here we've got A, B,
So,
C.
ma'am,
Yes. Yes, tell me.
yeah, this any what does it mean? Huh?
What does it mean?
It's a sample any this any in this
N.
No.
N is
formula.
number of commodities that you are calculating for.
Okay, thank you. Yeah,
So
I
here it
got you.
is, N will be equal to 5.
Yes, yeah.
Okay. So here, this is just another method, and you'll see there is a difference in the, I'm doing the same sum which I did earlier, but here the method is different. So the same question which I did here, the same question I'm writing again. Okay. So you've got price in 2020 and price in 2023. So price in 2020 is 50, 40, 80, 110 and 20. And here you have 70, 60, 90, 120 and 20. Okay. Now we calculate price relative. Okay. So price relative is what? P1 upon P0 multiplied by 100. So it will be 70 by 50 multiplied by 100. What is the value?
140.
140. Okay. Next one will be 60 by 40 multiplied by 100.
150.
150. Then the third is 90 by 80 multiplied by 100. How much?
125.
112.5.
1.5.
The next is 120 divided by 110 multiplied by 100. Yes? Answer?
100.09.
109.1 it should come.
Yeah.
Okay. Then you've got 20 upon 20 multiplied by 100. So this will come out to be 100. Now we will add these values. This will give you the sum of P1 upon P0 multiplied by 100. Please add this value. Yes, please type in the number in the chat box. 66.6. No. Add up all the values. 140 plus 150. Yeah, 611.6. Yeah. So you've got 611.6. Now you have to calculate P01 is equal to summation of P1 upon P0 multiplied by 100 whole divided by N. So here you can see N is equal to 5. We are talking about 5 commodities. So N is equal to 5. So here you have to calculate 611.6 divided by 5. What is the value you get?
2.32.
How much? 122.32. Okay. So what will you write as your answer? Correct. Everybody's got the answers correct. Yeah. So what will you write? You will write there is a 22.32% increase in price. So if you see, there's a difference between the answer you are getting by this method and the answer that you got from the previous method. So we consider the price relative method to be little better because it is giving you more specific answer. So it is giving you like 22.32% as a change, whereas that method just told you that it was a 20% change in. So you find that your result is much better, and that's why this is considered to be a little superior method as compared to the first method which we talked about. Okay. Okay. Is everybody clear till this point? Yeah. So we come to the next method. Now, next, there are a lot of formulas, but don't get confused. I will tell you exactly how to learn the formulas. It is very simple to learn and very simple to understand. So I'll come to the next page only to explain it to you. So these are called as your next area, weighted index numbers. Okay. They're called as weighted index numbers. And what is the weight we are giving? We are giving the weight of quantity to price. So suppose you say that, suppose I said the price is rupees 10 and the price is rupees 20, become rupees 20. Okay. But I am just buying 1 unit of this thing and I'm buying 1 unit of this thing. So that means here there is a maybe if you calculate it, you will see that there is an increase in the price. Now suppose I say that the next thing I'm buying is 10 units and of this I'm buying 5 units over here, and now the price has become 20. I am buying I have to buy 15 units of this. So you find that there's a big difference. Now this has become very expensive for me because I have to buy 15 units of this particular thing. So putting weights on different things will tell you the exact change in price, what is happening. Okay. So this is a very, very important method where we talk about index numbers. Now, there are different methods which are used. I will be dealing with 3 important methods. Okay, so the three important methods. The first one is, I'll just write the question down for you. So the first method is called as Lasprey's method. Okay, so the first method is called as Lasprey's method. So in this, we write P01 is equal to sigma P1Q0 upon sigma P0 Q0 multiplied by 100. Please remember, I'll just explain how this formula is easy to remember. Always remember that we will be writing sigma P1 and sigma P0. Only thing, in this case, we are taking base year quantity. So we are writing Q0, Q0. Is it clear? So this portion of your formula will remain same for all the formulas that I'm writing. Only you have to remember, in Lasprey's method, we use base year quantity. Okay? Now, when we go to the second method, it is called as Pasch's method. Okay, here we take new quantity rather than taking the base year quantity. So what will become to the formula? It will be P01 is equal to sigma P1 Q1 upon sigma P0 Q1. Can you see? Same thing. I have written sigma P1 upon sigma P0. But in this case, because I'm taking new quantity, I have written Q1, Q1. Okay, this has remained the same. Okay?
Teacher.
Easy to remember? Yeah, tell me.
Sorry, in the formula above, this of Lasper method, we put it here by 100. What about this second one?
This also, sorry, it will also be multiplied by 100. All formulas will be multiplied by 100 because we will take, we are taking the, in terms of percentage. So that's why you will always be multiplied.
Yeah, that is it.
Okay. Yes. So is it okay? Is everybody clear with these two formulas? Easy to follow? Now, the most important formula is called as Fisher's index number. Okay. Fisher's index number is basically taken as P01 and we take under root. But we take both of these, means you include Lasprey's into Pasch's method, both methods. So it is L into P. So how do you write? You will write the first formula. What is the first formula? Sigma P1 Q0 divided by sigma P0 Q0 multiplied by sigma P1 Q1 upon sigma P0 Q1 multiplied by 100. So this is your Lasprey's formula. This is your Pasch's formula. We multiply it. Is it clear? Is it clear? See, this is very, I hope it is easy for you all to understand and remember. So remember that this part of the formula, this P1 upon P0 is constant. Only thing, in Lasprey's method, it is base year quantity. That's why we write Q0. In Pasch's method, we want to use new quantity. That's why we will write 1. Okay? Okay? Yeah, everybody's clear with this? So we will do one question on this.
Yeah. Professor, sorry, I didn't get you when you was explaining this last formula of Fisher's index number.
See, here
this
you
last
just
letters L and P.
And Lasprey's method and Pasch's method we have multiplied. Yeah.
Okay, no problem. Thank you. Yeah. I got you. Thanks.
Yes. So let's do one question on it. The question is also very, very simple. Okay. So the question we are going to write, first we write commodity, that is A, B, C, D. Okay. Then we are going to take price for 2 time periods. So first I will take the price for 2020 and I will take the price for, in this case, we will take the price and quantity both. So price and quantity. Now this is the old time period. That's why this will be taken as, let me write it in another color so that you all can understand it better. That's it. Okay. So this will be taken as P0. This will be taken as Q0 because it is in the base year. Okay. So the one which is first means previous year. How do you know base year? Many times they will tell you that take this year as base year. But if it is not given, then the year which comes before is the base year. And the latest year will be the new time period. Okay. So similarly here we have 2023. So you've got price and quantity. So this will be
Teacher, sorry.
Yeah.
Yeah. Imagine if we have 3 years to compare. If we
No,
have
no, we don't compare it for 3 years. Under this
okay.
method, you can only compare for 2 years, 2 time periods.
Okay, thank you.
Okay. You have methods in which you compare for many years. Those are called as chain index numbers. But chain index numbers I'll not be doing now because it's a longer procedure. So chain index number is what we did in price relative. Like that, for different years, you can calculate price relative and you will come to know what is the change in the index which is coming. Okay, so by Fisher's index and Lastry's index and Parsh's method, we can only compare two time periods. Okay, so just write the values here. So this is 2, 5, 4, and 2. Then you've got 8, 10, 14, and 19. 4, 6, 5, 2, and 6, 5, 10, 30. Now, in your formula, if you remember, there are 4 columns that you actually need to calculate. 4 values that you actually need to calculate. For all the questions, there are only 4 values that you need to calculate. The first one is for P1, Q0. Then you have P0, Q0. Then you have P1, Q1 and P1, P0, Q1. Okay. Only these 4 values, if you calculate, you can do all the formulas together. Okay. So let us first calculate P1, Q0. So what is the value of P1, Q0? 4 into 8. That is, this is your P1 and this is your Q0. Okay. This one and this one. Okay. So, one second. Somebody wants to join. Just. Okay. So here the value will come out to be how much? 32. Then you have the next value as multiply 6 into 10, that is 60. 14 into 5, that is 70. 19 into 2, that is 38. So you will calculate sigma P1 Q0. What is the value?
Mark, can you come again where you are finding 32, 60, 70, and the 38? I'm not clear there.
200. 200.
200.
Yes.
Yeah. What are you not clear? This, see, this is the previous year. No, 220 is the older year. So older year is taken as the base year. So base year is always written as P0 and Q0. So price will be P0, quantity will be Q0. The new latest year is 2023. So that's why we have written P1 and Q1. So the first column that you are multiplying is P1 Q0. So this is P1 and this is Q0. These two columns we have multiplied. Is it clear?
Clear, ma.
Okay. So this is equal to 200. Now next we are going to multiply P0 into Q0. Okay. So that is 2 into 8,
16.
16. Then 5 into 10, 50.
50.
Then 4 into 14.
56.
Yeah. And last will be 2 into 19.
36. 38.
38. Okay.
8.
So this will give you the value of sigma P0 Q0. Find it out.
160.
160.
How much?
106.
106. Okay. The third column that we have is P1 Q1. So you will be taking, this is P1 multiplied by Q1. P1 multiplied
24.
by Q1. So 24. Then 6
30.
5s are 30. Then
50.
5 10s are 50. And 2 13s are
26.
26. This will be
26.
sigma P1 Q1. So
One
what
third.
is it? 100.
1/3.
Last is taken as a P0 Q1. So this will be P, oh sorry, why did it go to eraser? Sorry. This is P0. So we will be taking these two values. So this is P0
12.
into Q1. Yeah. So this is 12,
12. 25.
25,
40.
40.
26.
26, and sigma P0 Q1 is equal to 103.
103.
Okay. Now let us find out all the different things that we have to. So first we will find out Laspre's method. So that is equal to P01 is equal to sigma P1 Q0 upon sigma P0 Q0. So what is the value multiplied by 100? Sorry. So this will be P1 Q0 is 200 divided by P0 Q0 is 160 multiplied by 100. So this will come to
125.
100.
25.
Is it 125? Okay.
Yes.
So you will say there is a 25% increase in the prices. Okay. Second is Pasha's method. So under Pasha's method, we will get P01 is equal to sigma P1 Q1 upon sigma P0 Q1 multiplied by 100. Okay. So here it will be P1 Q1 is 130 divided by P0 Q1 is 103 multiplied by 100. Answer?
Then 126
126.
126.2. So here you can see.
214.
Okay. So we can take this as 26.2. So as I told you in yesterday's class, I know that is very nice you're writing till third decimal. Over here I'm just putting till 1 decimal just for convenience. But generally in statistics, we always take values till 3 decimal place. Okay. Now we come to the third method, which is Fisher's index number. So we will be taking both these things. So you will have under root of sigma P1Q0 divided by sigma P0Q0 multiplied by sigma P1Q1 divided by sigma P0Q1 multiplied by 100. So what are the values? It is 200 by 160 multiplied by 130 by 103 multiplied by 100. Okay.
One hundred 23.06.1.
How much have you, which table? Okay. Yes. How much is your answer?
123.1.
120. Anyone else also? Because anybody else finished? No, Khalid, it can't be 15775. I think you have to find out under root and then multiplied by 100. Yeah, square root you have to find out.
125,
Others?
yes.
Yeah,
125.6.
125. That's what I was wondering, because it will be 125.5, I think. 59, correct. 5 or 59. Yeah. Correct? Everybody is getting that?
Yes.
Okay. So is everybody clear on this method? This is a very, very important method, and normally you get a question on Fisher's index number. Okay. Now, with Fisher's index number, if all of you, I hope all of you finished with this question. So what happens is, now there are two important tests that we talk about. We talk about to find out whether the values are appropriate or not, and whether they are reliable or not, or those kind of things. We do two kinds of tests. So first we do a test which is called as time reversal test, and we do something called as factor reversal test. What does time reversal test means? Time reversal test means that if we suppose change the time, means currently in this question, in the same question, we have taken 2020, uh, 2020 as base year period and 2023 as new period. Suppose we change it. We say that no, we should take 2023 as base year period. That means P0 and Q0, and 2020 as new period. Means I want to find out the index number for that other period. Will the index still be able to do this or not? Okay, so that is called as time reversal test. Is it clear? So time reversal test means that you will change the time, numbering of the time. Okay, I will explain. So suppose we talk about Fisher's index number. Okay, so I'll come to first time reversal test. Okay, so when we talk about Fisher's index number, we say anyways this test is only satisfied by Fisher's index number. It is not applicable to any other thing. No other index will satisfy this particular test. I will explain, don't worry. So first let's write the formula that we know. Okay, what is the formula? Sigma P1 Q0 upon sigma P0 Q0 multiplied by sigma P1 Q1 divided by sigma P0 Q1 multiplied by 100. Correct? This multiply by 100, we don't need to just write over here because we are just doing the test. We are just seeing whether it is working or not. Now, what I have to do is I have to write P1 0. That means wherever I have written P1, I will write P0. And wherever I have written P0, I will write P1. Meaning that, see, over here I have written what? The first value is sigma P1 Q0. So instead of writing P1, now I will write sigma P0. So I've changed the time. Okay. First, this was for 23. I had written P1. Now for 23, I am writing P0. Then I have got Q0 divided by, over here, what I did write? Here I had written P0. So what will I write? Sigma P1 Q0. Okay. Is it clear? So I've just changed the time period. Means, see, earlier, I'll just write it. So 2020 and 2023. So first I had written P0, Q0 for 2020 and I had written P1, Q1 for 2023. Now I'm writing P0 for 2023, but quantity I'm just keeping same. There is no reversal in quantity. We're only changing the price. So over here, now I will write P1 and Q0. Okay. So I'm just changing the time period. Sorry, this will be Q0 and this will be Q1. So I'm not changing the Q part of it. I'm just changing P. Now over here, what did I write? I wrote sigma P1. So instead of that, I will write sigma P0 Q1 upon sigma P1 Q1. Okay. It's only the price that we are changing because the ratio is what we want to take. Okay. So now we have just reversed it. Now 23 has become the old means the base year, and I want to find let me just give you a very simple example, then you'll understand. Now suppose I said earlier that last year the price was 10 rupees and the price is increased to 20 rupees. So how much percentage change is there? Okay, this is Fisher's index test. Now suppose instead of this I say this year the price is 20 rupees and the last year's price was rupees 10. So how much the price has changed? Is it clear?
Ma'am, can you explain again in the second formula? I've missed a lot on P10.
See, only let me just draw it. This portion we are changing. So instead of writing 0 here, I'm writing it on top and this is coming down. Same way over here, we are just changing. This is the only area which is changing. Okay.
Okay, thank you.
Yeah. So now what do you actually find?
Sorry, I have a question on the same.
Yes.
So on this example, you are changing on the letter P. So can you also sometimes change on Q, or maybe you only change on P?
You can. No, you can change. See, we are doing price index number. If you are doing quantity index number, then the quantity will change.
All right. Okay.
Okay. So currently we are studying price index number. That's why we are changing the price. But if you're doing quantity index number, then we will be changing the quantity. Is it clear?
Yes.
So
Yeah.
now,
So
what
now,
do you want to
hello.
find out?
Sorry.
I come to question. Yeah,
Yes.
Manuel,
It,
just give me 2 minutes.
yes.
Let me just finish this, then I will answer all the questions. Okay, just
Okay,
let
but
me just complete this. Yeah.
yeah, I
So
would like to know if it's possible to change both the price and the quantity at the same time.
yeah, see, naturally, if this is P0 price, then this will be Q0 quantity, no? See, now when you're taking this as base here, this will be P0 and Q0. This is old quantity, so you're taking P1, Q1. Means you're comparing one to the other. So whatever you're comparing with will be the previous quantity, new quantity. Okay, let me just come to this. Don't get very confused. This is not a very important thing, but just I'm adding it. So you are just remember that instead of P1, you will write P0, and instead of P0, you will write P1. Okay, so what you need to find out over here, Salome, I'll come to your question. Let me just finish this. What we want to find out through this, then you will understand it is actually very simple. Not much has to be done. So here, if I see P01 multiplied by P10, what do I get is I will write down all the points. So here, first I will write down this formula. So what do I get? Sigma P1 Q0 upon sigma P0 Q0 multiplied by sigma P1 Q1 divided by sigma P0 Q0 multiplied by sigma P0 Q0 divided by sigma P1 Q0 multiplied by sigma P0 Q1 upon sigma P1 Q1. Now, what we are seeing over here is that if you see, now you have sigma P1 Q0 here and you have sigma P1 Q0 here. So you can cancel it out. Okay. Now, the next value that I'm taking is sigma P0 Q0 I have here and sigma P0 Q0 I have here. Then I have sigma P1 Q1 here and I have sigma P1 Q1 here. And the last, I've got sigma P0 Q0 here and, sorry, this should be Q1 and this. So if you see, it will come out to be under root of 1, that is equal to 1. That is all that I want to say, that even if you change the time period, the index number will still be correct. Is it clear? So you can reverse the timing, still the index number is correct. That is all that you need to do in this. Okay. So you don't have to recalculate the values. Nothing you have to do. You don't have to do any of this calculation. Let me delete this. You don't need to do any of this calculation. From the same table only, you can put in the values. Okay. So that will only get you the answers. So nothing has to be changed. We just have to put the same values. Only thing is it is put little differently. Okay. So we just want to say that if you take the previous and this current time period, you will not see that there is much change. The values will cancel each other out and your answer will come out to be 1. Okay. Is it clear? I'll do one question, don't worry. So you'll understand how your answers are there. Nothing is changing. You don't have to do any further calculation. You just have to substitute the values which you have put in. For example, in the previous question, can you tell me the values which you had? In the previous question, what are the values which you had? You had, let me write it down. So what are the values which you had? You had 200 divided by 160 multiplied by 130 divided by 103. Now, if you change these values, what was the value of P0, Q0? Please look in the table and tell me what you calculated in the question. What is the value of P0, Q0 that you have got? 160
What?
divided by?
Yes.
What is the value of P0Q1? What is the value of P1Q0? 200 multiplied by 103 upon 130. That is what is happening. You have just reversed the values. Now, if you see, all the values you've got are going to cancel each other out, and you will get this as under root of 1. That is, answer is 1. This is all that you have. Is it clear? So you are not actually doing any further calculation. You are using the same values which are there. Okay. Only thing what you did in the formula is, in place of P0, you wrote P1, and in place of P1, you wrote P0. Yes, Khan, you raised your hand.
Can we see the full page, please?
Yes.
The full page.
Yes.
Yes.
We have just reversed it. That is all that we have done. Nothing else has to be done. Don't go into too much of in-depth discussion. This is just just one simple thing. They say that in Fisher's index numbers, if you change P0 to P1 and P1 to P0, you will still get the answer of equal to 1. That means you can do time reversal test. Okay. Okay, that's it. Is this clear to all of you now?
Yes.
Okay. So I come to the second one. If you find it confusing, please do not go into it. It's not needed much. It's just an additional thing which is there. So I just thought I'll tell you this. The second is called as factor reversal test. Don't go outside the formula. Just think of the formula. Only that much we are going to do. Okay. So here we say P01 multiplied by Q01 is equal to sigma P1 Q1 upon sigma P0 Q0. What do you mean by factor reversal test? Where you have written P, you will write Q. And where you have written Q, you will write P. Okay. What does that mean? For example, P01, you have written sigma P1 Q0 divided by sigma P0 Q0 multiplied by sigma P0 Q1 upon sigma P1 Q1. Now, what did I say? Wherever you have written price, you will write quantity, and wherever you have written quantity, you will write price. So if I've written, I'll write it here so that you understand. Sigma P1 Q0. So what are we going to write in place of this? Sigma Q1 P0. Is it clear? So in place of price,
Yes.
I've written quantity. In place of quantity, I've written price. Okay. So what will I write for the first one? Sigma Q1 P0 divided by, what will be the second one? Will become what? Sigma Q0.
Q0 P0.
Okay. So it will be Q0 P0 multiplied by sigma Q0 P1 upon sigma Q1 P1. Clear? So this is your quantity index number. Is everybody clear on this? In place of P, we have written
Yes.
Q. And in place of Q, we have written P. Now, let us multiply these. So you've got sigma P1 Q0 upon sigma P0 Q0 multiplied by sigma P0 Q1 divided by sigma P1 Q1. multiplied by, I will write the quantity index number, that is sigma Q1 P0 upon sigma Q0 P0 multiplied by sigma Q0 P1 upon sigma Q1 P1. Now, can we cancel any values out? Please see and tell me. Sorry, this is P0 now. This value is P0. So you find the first one we can calculate is this. There will be 4 values which will get cancelled out.
The same as the previous one. It's 1.
Yes, same as the previous one. Yeah, correct. So you'll just be left with 2 values. One value, I think that Q0 P1. Yeah. So this and this will cancel. So you are left with what? You are left with sigma P0 P1 Q1. Sorry, P1 Q1 multiplied by sigma P1 Q1. If you write this again in the same manner, this will be the same. P1 Q1 divided by sigma P0 Q0 multiplied by sigma P0 Q0. Okay. I'll just correct it. So what do you get? You will get outside, if you take it will be sigma P1 Q1 divided by sigma P0 Q0. Okay.
Yes, doctor.
Yes, tell me.
When you get the sum of P1 Q0 with sum of P0 Q1, it's not same.
It's same. See, you're
P1
multiplying
Q0.
those 2 columns. So whether you multiply 2 into 5 or you multiplied 5 into 2, you will get the same answer of 10.
Okay.
So suppose I say this is P0 into Q0. So this is 10 and Q0 into P0 will also be 10. We're getting the same. Okay. What? Yes. Wrong. Sorry, everything this wrong. That's why I was wondering what is happening. This is Q1 upon Q0. Okay. Okay. Is it clear? So what is the factor reversal test giving us? So now if you want to put all the values of the previous question and you will cancel out, you will get the same answer, that it will come out to be sigma P1 Q1 upon sigma P0 Q0. Okay. Is it clear? Can you all substitute? I'll just give you 1 minute. Find out if you're getting the same answer. Please find out if you're getting the same answer. As sigma, because I have to keep going back to that question, that's why. Just calculate whether you are getting the answer of, I'll write that answer. Just tell me if you're getting that answer. What is sigma P1 Q1? 130 divided by Don't have to solve it further. Okay, 130 divided by 160. Are you getting this answer? Put in all the values and cancel and see. Are you getting this answer? Please calculate and tell me how many of you. I'm giving you 1 minute. All of you, please substitute the values and tell me that whether you're getting the same answer. Yes, Sifo, you've got the answer? Please substitute in this P01 and Q01 and tell me if you're getting the answer. Just write a yes the moment you finish, or show me a thumbs up the moment you're getting the correct answer. Okay. I'm not substituting. I'm asking you to substitute. Okay. Yes, Sifo, I saw your hand up. What about the others? There are nearly 50 people here. Let me just see maximum of you telling me that you've got this answer. I'm giving 1 minute. Yes, what about others? Anyone else finished? Okay, Nirmal, very good. Others? So basically we say that Fisher's index number satisfies both factor reversal and time reversal test. Okay, so we will say Fisher's index number satisfies both time reversal and factor reversal test. Others, can I see some more hands going up? Then I'll go to the next concept. Yeah, what happened? Manuel, have you finished? Ibrahim, Isaac, good to know you finished. What about the others? Ravi, have you finished? Sahir, Khalid?
Not yet.
Okay, please do it. Yeah. Rajkumar, I'm just reading some of the names I can see, but I'm asking all of you. Yeah. Okay, others, Tanya. Just write a yes the moment you are finished so that I know how many of Mustafa. Yeah. Yeah. You finished?
B1? Yeah.
Yeah. Okay. Good, good. Yes. Slowly I'm seeing all the hands coming up. I'll give another 2 seconds and then I'll come to the next concept. That's the last concept. It's a very important concept again, where we talk about hypothesis testing. And that will be the last part of this course. And I hope you all do very well after that. There are a lot of other things also, but given the number of hours that we have, I think I've tried to cover majority of the portion of the course. There will still be a lot of things which you all will need to read up on your own also and solve on your own. But generally, at least all the important concepts, the base of all the important concepts, I've tried to cover in these classes. Okay. Yeah. So let me go to the last concept, otherwise we'll not get time. So the last concept which we will talk about is called as hypothesis testing. Okay. Now, when we talk about hypothesis testing, it's a very important part of any research. Now, suppose you want to find out if there is a difference in literacy in rural and urban areas. Okay. No, we didn't do probability, Yusuf. We don't have time for probability, but this is an important concept. So I'm doing this area today. Okay. Yeah. So hypothesis testing, when we are talking about, it basically means that you are going to test whether anything, any research that you do, you always are testing. So suppose you say that IQ is same for male and female. Okay. Or I say literacy is same for rural and urban. So different areas you will find that literacy is same for rural and urban. So you want to test now. Automatically, you know that if you think of any of these, you will not. You know that it is not same. It will be different. Okay. So generally for this, let me not discuss gender. So suppose I say that literacy is same for rural and urban areas. This we know is 100% coming out to be wrong. We will find in our result that there is a difference between rural and urban population. So I want to prove that there is a difference between rural and urban population. But when I write the hypothesis, I will always write that there is no difference between rural and urban population. So that is how we test hypothesis. So whenever we are making a hypothesis, there are two hypotheses. You will be having null hypothesis and alternative hypothesis. So whenever we talk about the null hypothesis, it is written as HO. Okay. We always test for null hypothesis, and the null hypothesis will always be that there is no difference. So we always assume there is no difference. There is no difference between male and female in shopping. There is no difference between rural and urban area. There is no difference between spending of very rich people and very poor people. So when we say that there is no difference, we are talking about the null hypothesis, whereas the second is called as the alternative hypothesis. There you will write there is difference. So what will we write? Literacy is the same for rural and urban areas. Okay. This is your null hypothesis. Alternative hypothesis will be that literacy is not same, is different for rural and urban areas. So this is always, whenever we write a hypothesis, we will always be writing these two hypotheses. One is called as your null hypothesis. The second is called as your alternative hypothesis. Now, whenever we do any kind of testing, we will always do a testing according to a certain level of significance. So in the level of significance, we say that there are two level of significance. That means, see, 100% correct, no research can be. Okay, there, because we are studying human beings, we are studying areas, we are studying so many different things. There will be some people or some areas which might be different. I said that rural and urban areas literacy is not the same, but it can be possible that in one village the head of the village is very conscious of this, and he might bring about literacy for everybody who's staying in that particular village. So there can be 100% literacy in only that particular village. So there are always exceptions whenever we talk about human beings. That's why we say that we cannot take 100% significance level. So we test always at 99% level, and we test at 95% level. So we will say that if it is 95% correct, then it is okay. Means 5% there can be some odd cases or something which is wrong. But 95% if the hypothesis is correct, that means it's a good hypothesis. And the other is, if people want very high level of accuracy, then they will say that no, I want only 99%. Only 1% chance of error is there. But 99% we will have to have correct estimation. Okay. So whenever we talk about this, we talk about a normal distribution curve over here, and we will see that, suppose this is your normal distribution curve. Okay. The center area is, we say, is your population. Now over here we will say that suppose the value fall between this to this area. This is called as our acceptance region. And this side and this side is both rejection. Means if the value is falling over here, we say no, it is outside. That means the null hypothesis is wrong. That means which hypothesis is correct? That literacy is not the same for rural and urban areas. But if the value is falling in the acceptance region, we will say we will accept the null hypothesis that literacy is the same for rural and urban areas. So that is what we will try to predict through this. Now, it is this is a simple thing where we said that literacy is same for rural and urban areas. So here we have a central acceptance area. Now suppose I want to give you another example, that suppose I say that there is a machine which is filling milk, okay, and it is filling 500 ml milk in each packet. Okay. Please listen carefully. Now, I said there is 500 milk in each packet. So, this is my null hypothesis. So, I have made this hypothesis that 500 ml milk in each packet. Now, what will be the alternative hypothesis? We will say it is not equal to 500 ml. Means it can be more, it can be less. So if I'm saying it is not equal to 500 ml, that means I have this area where I'm saying that it is not equal to, it can be less than 500, it can be more than 500. Okay. So this is one hypothesis. Now, second hypothesis can be that the milk is always less than 500 ml. Okay. Is it possible that in every packet when you're filling, the amount of milk which is there is less than 500 ml? Okay. The third hypothesis can be that in every packet the milk is more than 500 ml. Clear? So there can be three alternative hypotheses depending on what you want to test. So one hypothesis can be that it is not equal to 500 ml. Second hypothesis can be it is less than 500 ml, and the third hypothesis can be that it is greater than 500 ml. So there can be different kinds of hypotheses that we can make depending on different questions that we have taken. Okay. Now, if I'm taking at 5% level, then these areas are taken as, in this case, it will be taken as the value will be uh, minus 1.96 and plus 1.96. So if the value is between minus 1.96 and plus 1.96, we will say we will accept the null hypothesis. This is called as acceptance region. Okay. So if the value lies between these two values, we will say the null hypothesis is correct. Are you following me till here? Are you following me till
Yeah.
this point?
Yeah. Yes.
Where have you obtained one negative 196?
Always the area will be between positive and negative. The central value, if you take as your center area as 0, so this side it will be negative and this side it will be positive. That way. Okay. The center area. So if you remember when I talked about dispersion, I said no, there can be values. Suppose there are values like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if I take 5 as the value, all these values will come out to be negative. All these values come out to be positive. No, correct?
Yes.
Yeah. So same way in this also, we will have a negative and a positive region. Now, what
Okay.
happens over here, and this is a very important question again, what are the two different kinds of, Khalid, I'll repeat. Let me just finish this, then I'll come back to it. So, when we say that, when you're doing hypothesis testing, there are two types of errors which come. This is a very important question, very frequently asked. Okay, so there are two types of errors. So what happens is, I'll just draw this chart so that it is easy for you to remember. Accept HO, reject HO, and I say HO is true and HO is false. So if HO is true and I accept it, then this is correct decision, no? Correct? So null hypothesis is correct is true and you have accepted it. Then it is called as correct decision. Now the second one is when we say HO is true, but you reject it, then this is a wrong decision, no? So wrong decision means this is called as type 1 error. Okay. So if the null hypothesis is correct, but you are rejecting the null hypothesis, then it is called as type 1 error. Then the second one is, if null hypothesis is wrong and you accept the null hypothesis, then also there is a wrong decision. So here again you have type 2 error. Okay. And if null hypothesis is false and you reject it, then this is again a correct decision. Is it clear? So over here you have type 1 error and over here you have type 2 error. Is it clear? So what is type 1 error? Type 1 error is that null hypothesis is true but you have rejected it. What is type 2 error? When null hypothesis is false and you have accepted the null hypothesis. Clear? Okay. Okay. Is everybody clear here?
Madam, I've got a question.
Yes, tell me.
Could you give us an example as whereby an on the null hypothesis being correct and then you end up rejecting it? What would be a practical example on it?
See, for example, I say that, because of the sample that you have collected. Okay. Now, if I say a null hypothesis is true, That means, suppose I say there is no difference between the IQ of men and women. So suppose I say that this is a correct hypothesis. But what has happened when you have taken different kinds of values? There is a error in your value. Suppose you were supposed to put the value of 100, but you have put the value as 1000. So what will happen? The whole answer will change. And maybe because of that, you will reject it. So what has happened? The hypothesis is correct, but because of your error, some calculation error or estimation error, you have got an answer which is wrong. So you have rejected the hypothesis. That means it is a type 1 error. Okay. So you will come to know, and then you'll have to go back and correct it. Okay. Yeah. So now, according to this, what happens is we have many different kinds of tests. I can't do all of them, but I'm just telling you that you will have something called as Z test. Then you have T test. You have ANOVA test. Then you have chi-square test. So you will have many different kinds of tests which are used to do the hypothesis testing. Okay. So for example, Z test is used for large samples. Then T test is used for small samples. ANOVA is, when you want to test values related to regression analysis and other things, you use ANOVA testing. Chi-square test is a test where you are taking two variables and you want to find out whether there is an association between the two variables. For example, you say there is flu in the place. So how many of them are benefiting by vaccination? Okay, so if you want to test this, then you will use association of attributes test, which is called as chi-square test. So different tests will be used for different things. Okay, so I'll just come to the first test. I'm writing down one question, so please write it with me, because without writing the question, you will not be able to solve the test. So I'll just write one simple question over here. Just give me one second. So suppose the question is that a manufacturer developed developed a fishing line and claims that it has a mean breaking strength of 8 kgs with standard deviation of 0.5 kgs. If a random sample of 50 is tested, and found to have a mean breaking strength of 7.8 kgs, test the manufacturer's claim. Okay, so here they have said use 1% level of significance. Means use 1% level of significance means 99% your answer has to be correct. Means if it is within 99%, then only you will accept it. Only 1% of results will be rejected. Okay. So here we will say first, what is the mean value that he has given? He has given the mean value of 8 kgs. Okay. So he says that my fishing line will have a strength of 8 kgs weight. Okay. And what is the standard deviation? Standard deviation is given as 0.5. Then what is the sample size? Sample size is written as n, that is equal to 50. If you see over here, this is 50. Okay. And the last value which we have is x bar. X bar is what? X bar is the population mean, sample mean. See, this is for the sample, this is for the population. What do we mean by that? Now, suppose the manufacturer is making 3,000 fishing lines. Okay, so he's saying that all these 3,000 fishing lines that he's making will have a mean breaking strength of 8 kgs. Means they will take the weight till 8 kg. At 8 kg, they might break. That is what he's saying. Now you want to test it. So what you have done is, out of this 3,000, you have taken a sample of 50. And from the 50, you have calculated mean. So you have got that mean as 7.8 kgs. Now you want to see whether this is within acceptable rejection limits. Means exactly 8 will not come. Okay. As I told you, you will not get 100% the result which anybody is saying. So he's saying 8. You have got 7.8. Is it within the acceptable region is what you're trying to test. Is everybody clear till here? So for the population, that 3,000 fishing lines which this manufacturer is making, that is the population, because that is taking all the fishing lines which are being produced. So that is the population. Out of that, you have taken 50. So sample size is 50. And of this 50, the mean that you found is 7.8. So it is the sample mean. Is everybody clear on this? This is very important. Okay. So what is the hypothesis? Null hypothesis will be HO, that is, you say mu is equal to 8. Okay. And alternative hypothesis will be HA, mu is not equal to 8. That is what I want to find out. Okay. So he is saying it is 8. You have seen that it has come out as 7.5. So you want to find whether we can accept the person's claim or not. Okay. Now, here, how do we find out? We use something which is called as standard error. Okay. So how much of error is admitted? That is taken as standard error. How much percent error are you wanting to say it is okay? Like we'll say, no, it's okay if I'm buying some 500 pieces of fishing line. 1-2 can go wrong. 1-2 can break at 7. 1-2 can break at 9. So it's okay. Normally when we buy a lot of things, we say no, it is okay if one odd piece is not broken or not working fine. So that is the standard error that we are talking about. So here we say standard error is taken as standard deviation upon under root n. So this will be 0.5 divided by under root of 50. So this value I'm giving you here is 0.07. Okay. Then what we need to calculate is the test statistic. What is the test statistic? Test statistics means the calculated value of Z. Okay. So it will be test statistic of Z. That means basically here this is called as the calculated value. Okay. So what is the calculated value? it is taken as absolute value of x bar minus mu 0 divided by standard error. So this is taken as 7.8 minus 8, means positive negative sign will not come. Okay, so it will be 0.07. Please find this value and tell me. Yes, anybody?
Point 85.
How much? 2.85. Correct.
Yes.
Okay. Now, if I'll just go back to the previous page, so that I can just explain. Now, this is the value I had said is at 90 at 5% level of significance. So for 5% level, the value was 1.96 and minus 1.96. So for 99% level, the value over here is taken as minus 2.58 and plus 2.58. Okay, so this is the acceptance level for 99%. This is 5% level, means 95%. Okay, now what do we have to see? What is the table value? See, what is given value is called as table value. Zero point zero one. 0.01 means 99% level. Okay. So what was the table value that you got? 2.58. Okay. So it can be plus and minus, but since this value is positive, here also we are comparing with the positive value. So what do we find? Now this is most important. Okay. Now what are we seeing over here? We see that your, let me enlarge this. Okay, only this portion is important. So now see, we say calculated value and table value. Which is greater? This is 2.85 and 2.58. Which is greater? Calculated value is greater than the table value. That means we will reject the null hypothesis. Okay, so what are we going to say? That that person's claim that it is 8 is wrong. It is not 8. It is less than 8. Okay, how did we reject it? I'm going to the previous place just to explain this again. If you see, this is the value of 2.58. So here will be the value of 2.85. So it is in the rejection area. Is it clear now? It is more than 2.58. So it is going in the rejection area. So we have rejected the null hypothesis. So what are we going to say? Manufacturer's claim is wrong. Okay. Yes, Munir? 2.58, I told you, no, these are table values. These are fixed values. Means what we have done over here, we have calculated. But we, if you have any statistics books or you have your, if you have any of your tables with you, in behind your statistics books, there are different tables which are given. So in that table, there are fixed values. So for Z test, there are two fixed values. Please remember them, learn them by heart. At 99% level, it is plus 2.58 to minus 2.58. And for 95%, it is minus 1.96 to plus 1.96. These are fixed values. Now, these fixed values tell you what is the acceptance region and what is the rejection region. So what you do is you will calculate your value. Now, if your value is falling within these values, you will accept the null hypothesis. If your value is falling outside this, then you will say that it is wrong. Okay, the null hypothesis is not accepted and you will accept the alternative hypothesis. Is it clear? Is it clear to all of you?
Yeah. Hello,
Yeah.
ma.
Yeah,
Please,
I
ma,
will
I
do
need
one more question on this because more than that, I think we'll not be able to finish. So let me at least write down one more question so that you are more clear on this. Okay?
please, ma. Can you hear me, please, ma?
Yes, tell me, Munir.
Okay, please, I need more clarification on the table value.
See, table value, you just need to remember these two table values. They are fixed values. For everything in hypothesis testing, you have values which are, I can't share that with you because there are values which are given in the, just go to your statistical notes, the books which you've got from IGNU also. In the last page, you will get those tables where it is written as Z table, T table, chi-square table. Those values are the fixed values. We always have to compare with the fixed values. So the fixed values are predetermined. It has been calculated and it has been said that these two values are the maximum limit for 99% or 95%. There is also 165%. So different values will be telling you about how many values can come in that distribution. Okay, so they are fixed values. So when they're fixed values, you will need to learn these two values. Is it clear?
Yes, ma, it's clear. Thank you.
Yeah. So let me
But
just
as
write one last question over here because more than that, I just want one more practice question for you all. So we'll just do one more question over here. Okay. So I'm
Yes,
just
ma'am.
writing. Yeah. Okay. So a stenographer claims that she can type at the rate of 120 words per minute. Can we reject her claim on the basis of 100 trials in which she demonstrates a mean of 116 words with a standard deviation of 15 words. Okay, use 5% level of significance. So in this case, what are the values we are going to take? We are going to take plus 1.96 to minus 1.96. Okay. So now if you see what is the information which is given to us, I'll just write down. She can type. What is she saying? That she can type at the rate of 120. Okay. Second is how many trials, how many samples have we taken? 100 trials. That means N is equal to 100. So we have seen her working on this 100 times. Then what did we find as something which she can do? That is 116. So every time she is typing 116 words she can type. And we have got the standard deviation as equal to how much? 15.
15.
Okay. So first, what do we calculate? First, we will write the hypothesis. So what is the null hypothesis? HO is equal to mu is equal to 120. Means the person can type in 120 words. Alternative hypothesis will be mu is not equal to 120. Okay. Then what do we find out? What is the next step? Can you tell me? We find out standard error. So that is SE is equal to upon
Standard
under root,
deviation.
that is 15 divided by under root 100. What is this value?
1.5.
1.5. Then what do we calculate? Calculated value of Z, or it is called as test statistic Z. What will it be? Absolute value x bar minus mu upon standard error. So this will be 116 minus 120 divided by 0.5. So this is, what is the value you're getting?
Four divided by 1.5.
Yeah. So what is the value?
2.66.
2.67 minus.
Okay. Yeah, minus. But we are taking absolute value. That's why we are not adding the negative sign. Okay. We are taking this absolute value, no? So that's why we will not write the negative value. Correct. It is minus 2.67. Now, can you tell me at 5% level of significance, what is the value of Z?
1.96.
95.
1.96.
96.
Now, what do we find? You will write which is greater, test statistic or table value. So, test statistic is 2.67 and table value is 1.96. Which is greater?
Test statistic
value.
Yeah. So, what is your answer over here? What are you going to say?
We are going to reject the tabulated value and accept
reject H0.
Yes. So what is your answer? You will say that the stenographer's claim is true or not true? Tell me.
True. It's not true.
Is not. Okay. Is it clear? Is the question clear?
Yes, ma'am.
I've got a question, madam.
Yes.
I'm kind of lost at how you got the 1.96.
See, as I told you first also, that these two values are given values. Okay, these are permanent values. So any kind, like if you remember over here, when I drew these two diagrams, I showed you that these areas, these two values are given as fixed values. So these values do not change. See, whenever we test something, we have to test it against given values. So these values at 5% minus 1.96 plus 1.96 and 99% minus 2.58 to plus 2.58 are given values. Okay. So we have to calculate our value and see it in comparison with these fixed values. That is what we are doing. Okay. Yes, Mike, what is your question?
Ma'am, I'm inquiring something.
Yes.
On test statistics Z, you said 1x mean minus that formula over standard error. Then you used the 116 minus 120 over 105. Then you got 4 over 105. May I please know how did this 4 come?
4. Which one? This
On
is a
this
question.
on the second question, the question that we are attempting,
Yeah, this
on
second question.
yes,
Yeah,
on test
yeah,
statistics, where on that test there is where you got 2.67, but
yeah.
I did not know how you got the 4 over 105.
4.
Here,
Which
here,
4?
here, 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 here. This 116 minus 120.
Yeah, this
What
is
does this
from the.
what does this mean? What does this sign here mean, and even this
It,
one here?
it means that the stenographer said that I am typing 120 words per minute. So she says that I am typing 125 minutes per words per minute. But what you have done is you have taken, you have asked her to type 100 times. Now, in these 100 times, you found that she has generally been able to type only 116 words. So we want to find out whether her claim that she can type 120 words is within the uh, acceptable region or not. So what we found was that it is not correct, that she is not able to type those 120 words. She is typing less than 120 words. Is it clear?
I'll try.
Okay, yeah.
Mm.
Because that is what you are trying to see, like I told you in the beginning only, hypothesis testing basically tells us that to a certain level only we can be correct, we can never be at 100% level correct. Okay, so you might say, as I gave you an example, suppose you go and buy one box of 50 bulbs. Now, all 50 bulbs will always be okay, does not happen. There might be possibility that if you are buying 5 boxes of 50 bulbs, there might be one odd bulb which is not working. Okay, so that much error we permit. Now, if that one bulb is not working in the whole box, we will say at 99% level that yes, I think majority of the bulbs are working only, and it is a good claim. But suppose in one box, now you bought that box of 50 bulbs, and out of 50, 20 bulbs are not working, then that is a naturally a big error. Okay, so that is what we are trying to test, whether if anybody is making a claim, whether the claim is correct or not. Okay, yes, the table 1.96 will remain constant, that is a constant fixed value for 95% level. And there is you will have to go, Munir, you will have to go and see the Z test. Even if you type it online, you just type Z table or Z values, you will get the values. So if you just write Z value at 99% level, you will get the same values. If you write Z value at 95%, you will get the same answer. Okay, so these are fixed values which you will get. For some other testing methods, you also have to use the table and calculate the values. Okay, I hope that clears your question. I can't share the screen like that, otherwise I would have shown you how it is calculated. Let me see.
Ma'am,
Yes,
is it possible if I can access the first notes? I missed some notes at the start of this lecture.
I think the recordings are available, so maybe from there you can take it up, because I don't have
But
the notes or the recording, so
we
you'll
can't
have to take
access
it up.
those recordings. On LMS, there is nothing. There is nothing we can access. We are
Okay.
going through a very hard situation. Once you miss the lecture, you have missed everything.
Oh, because that you'll have to see. I'm sending a link, or if you can just see this, if you just open this link, you can see the values are already given. Okay, just see, Z score is given, p value is probability that you can leave, but just see the Z value for 3 values it is given. Can you all open it and see in another, you can just click on the link that I have given. Okay, you can just see this is one of the links, but you'll get a lot of links telling you the same thing. And 1 minute, I'll see if I can share the picture of one of the tables. But you don't have to go to a table for this, because for this you know, it is always the same values which you will have. Okay, let me see if I can paste it here. I think it is pasting. If I could paste it, I would have pasted this. 1 second, just give me a second. Let me see if I can paste it for you. Yeah, just give me 1 second. I'll just try. If I can show it, I will show it to you. Are you able to open that link? That link also has it. No, I'm
Nope.
not able to.
Nope.
I have put it in the chat. Just click on that. Just copy paste it in Google. You'll be able to open it. Not able to open. Okay. 1 second. Let me just try. If I can send it to you, I'll send it to you.
So while you are trying to share the screen, I have some questions related to the exam date. Is there a possibility for us to have some kinds of materials such as formulas that we can have in papers, or we can consult the material that we were given through our portal? I don't know.
Actually, whatever extra is there, that I think you can contact the study center. They can let you, because we have just been allotted these classes. So that's why I have tried my best to cover as much as possible. So I have shared the link also. Now I think you all will be able to open it also.
Okay. I was just asking because you are our lecturer, and I hope you have experience with others that came before us. Yeah, so that's why I was asking. Thank you.
Yes. Okay, but I hope we just are about to finish with the lecture. So I hope whatever I have taught you is clear to all of you, whether it is this subject or whether it was business environment. I hope you could understand all the lectures that I had with you all. Yes, I hope that was clear, because this is my last meeting with you now. So that's why I just wanted to get a small feedback from you all, that I hope you were clear on all the lectures that I have shared the link again also. Just scroll up, you'll find it. It's just one of the links. You will get enough material on this. Okay.
Yeah, we have started accessing the link, and surely the material is here. So,
yeah. Okay. So you will that will be useful for you to understand how it is working, because as I told you earlier also, the number of hours are limited, and this is a huge course. So actually, when we teach in a class, it is nearly 6 months that we teach, and it is so much. So it is whatever best is possible, I have tried to cover in the 8 hours or 8 hours, I think, that we had. Okay, so all the best to all of
teacher,
you. Yes.